We are live. This is yet another Ask Us Anything session. And today we are focused on stateful applications, specifically in Kubernetes, but doesn't have to be. And I have a great guest here, amazing guy, Nick from OnDat. I will let you introduce yourself, Nick, and then we go with questions.
So hi, Victor. Hi, everyone. I'm glad to be there. So I'm Nick. I'm a principal developer with OnDat. So OnDat, we provide distributed storage for Kubernetes, stateful application. So very glad to be here. And again, thank you for having me.
Brilliant. Let's start with, stop. Not let's start with questions. Now you watching should start writing questions and do that fast because he's a very fast talker guy, so he's going to answer them all in 2 minutes. We have one that came before this stream, so we're going to start with that one and then see from there on. So, stateful set for DBs, to be or not to be for large and medium production environments. Is it secure or still better to keep DB in pass, backend kind separation? I have my very strong opinion on that, but I'll let you answer first, Nick.
If I don't have the same, I'll be in a bad spot. So,
it's going to be fight.
Okay, so, I'm always like, it depends. That's always the right answer. Seriously.
Try again.
Okay, I'm going to try again. I would say it still depends. Just joking. So stateful sets, if you ask me, a couple of years ago, the problem is they were not necessarily ready as a construct to start to begin with, within Kubernetes for scale, for big production database, these kind of things. So now most of it has been solved. What hasn't been solved yet, I think, is not necessarily on the Kubernetes side, but how you manage the database on Kubernetes. So you can see there's a lot of operators out there for databases. Some of them are doing a good job and some of them are not so good. So I would say it also depends on the operator and how the operator will allow you to operate not only the Kubernetes environment, but also the database. Because when you scale a stateful set, for example, so you scale the number of containers, right, with the database image, but the database doesn't scale. Or how do you do backup? All these kind of things. How do you create new users? So of course, Kubernetes has a lot of benefits when you have an operator because of the automation it brings. So I see all of that as benefits. But at the same time, if you do things like encryption or, using, a volume encryption and store secrets in etcd, and if etcd is not encrypted itself, is useless. So there are still a lot of pitfalls to avoid inside Kubernetes to run those databases at scale in your environment. So it's half and half, I would say. But for me, I would definitely run database in production in Kubernetes to make it simple.
Okay, then we agree. We have similar answers. I was about to say it really depends on the database. Some databases adapted to Kubernetes well, some didn't. Some new were written specifically to leverage being cloud native, not necessarily Kubernetes. And if you pick the right database, then the answer is if you know what you're doing. In Kubernetes, kind of like it's not the first thing you do in Kubernetes. It's not, hey, look at this, I got my first cluster. Let me run a database. Done.
Yeah. Oh, it depends. Anthos migrate. This is what they migrate VM to containers, which I'm not sure it's a good idea if you don't know Kubernetes, don't run stateful application. You're right. That would be crazy.
All those migrations like lift and shift, I always see them as this is okay only if this is very temporary. If you're doing this only until you transition to the good thing, whatever the good thing is. Now, in practice, I think that people lift and shift and then, okay, so we are now 5 years safe. Kind of like, we're going to get a lot of benefits. We're going to get so much benefit that we do not need to do anything else. And then it's
we can just relax. No.
But what I will also add is that the best place to run a database is not to run it yourself. If you can afford, if you can afford kind of like AWS or Google or Azure or whatever, some kind of, it's not me, kind of like I just connect to my database and use it from my application. That's the best option.
Yeah, but I also think, it's a matter, again, with regard to the scale, things like RDS or any DB as a service can be super expensive. So you can have it in between. You can run a managed Kubernetes environment in the cloud, consuming a managed Kubernetes, just cluster. And then nothing is preventing you from adding EBS volume and, installing a database there. So it's like half, right?
Yeah. So it's a good option if you're rich.
I don't know, EKS is not, compared to RDS, I'm sure EKS bill will be a lot less if you run things in Kubernetes, because my experience with RDS and all the reserved IOPS and all these kind of things, if you can find a solution in Kubernetes, even leveraging like your local drives, like the ephemeral storage, like, of course, if you use a solution like, I'm talking about on that, but any other ones that provide you this kind of replication, you don't have to use necessarily EBS. As long as you make sure you have proper operations, you can just fill up your EC2 instance just with a local storage like SSD or NVMe, and this storage is typically ephemeral. So the problem is, if you lose your storage there, by default Kubernetes doesn't replicate anything, right? So you kind of screwed. But if you have a solution that replicates and can handle this transparently, then you can even save more money by not having to just buy those reserved IOPS super expensive drives.
Okay, what's the next? When talking about stateful apps, we cannot ignore backup snapshots, volume snapshot, cloud provider, this snapshot, blah, blah, snapshot. Focuses on backing up persistent volumes and not enough. Okay, so this is me now asking you, Nick, because I really don't know as much about it as you can.
Yeah, so...
But, isn't it that backing up persistent volume can, while something is writing there, that might not produce the results, right?
Yeah, so I think there's two levels. So talking about stateful app, of course, data is persisted to disk, so you need a way to back it up. In my opinion, right, snapshot is fine as long as you have just a file system and do like an FS freeze or something, that's okay. If you have a database, the snapshot won't help you if you just do that. The snapshot becomes the foundation to do something else in advance. Like you have to freeze your database. You have to make your database in a state where you can take a hot backup of it. So snapshots alone will back up, but the restore may be another story here, right? So my advice is really use the right tool for the right job. So snapshot is good as a foundation, but then you need to have the proper agent or application framework that will not application but tool set framework that will allow you to run script to freeze your database. Things like Canister or I think Valero, they have these kind of things where you can mix both.
Well, before going to the next section, next question, very quickly. Subscribe, like it, and join the channel. I'm watching you. I know who you are. I'll go after you if you don't do that right away. You don't have to join, but at least subscribe and like it. Okay, that was a quick commercial announcement. What's next? What do you think about using NFS as a backend storage? Never mind latency. Do you see NFS PVS in cloud native workloads?
Yes.
Okay, so here's the question for you. Sorry, question before this question. NFS is one of the oldest technologies we have in a stack right now, right?
Yes, I think so.
Kind of like, is there anything that older than that we are using today?
I don't know.
Okay,
In terms
sorry.
of software,
Continue.
probably like embedded stuff in your everyday, kitchen, or I don't know, maybe all.
In a fridge that you have from 70s still, okay.
Yeah, maybe. So NFS, so definitely not for a database, right? But as a way to, the challenge is, right? If we talking about stateful sets, stateful set is a special construct in Kubernetes. So a stateful set typically use a volume claim template, and every pod ends up with its own, PV or NPVC. NFS is a bit different. NFS can also back normal deployment, like they can all share. It has to be a shared file system, and NFS is good when you need a shared file system for sure. For database, I would still, and you will see all the operators for anything stateful that is, that is something critical, like database, message queuing, all of that. You will all ML workloads. You will always have stateful set, and therefore most of the time you will have dedicated storage for every pod, which is backed then by PVC and PV, and it's just disks that are directly attached. So NFS, yes. Basically, you can just consume NFS PVC, read write many. That's perfectly fine. But again, not for a database, but for basic file system. I don't see any objection to this. Having NFS is always useful everywhere. As you said, it's probably one of the oldest technology out there anyway. But I guess it's also the difference between SAN and NAS. It's why? If you want performance, you don't go over the network. It's a simple. That's it. What do you think?
No, I'm definitely not. This is why I like this conversation, because I'm not that deep into it. So I don't know all the intricacies and details and stuff like that. Like, what do you think about distributed storages like Ceph? Is that the thing?
Yeah, Ceph is. I see it with customers. I see it with people. Now, I don't want to bash open source solution or any other solution like.
I meant kind of like Ceph-like, let's say.
Ceph-like.
Yeah.
So all of the solutions are valid, but again, it depends on the workload. So my advice is whatever solution you want to pick, just test your own application, right? And test things in a way that are relevant. Like if you want to compare a storage solution, don't test a storage solution with 2 disks and another one with 100 of disks. And it doesn't make sense. And Ceph is kind of this thing as well, where you have to bear in mind, you have to pay attention to what you're doing. Performance is usually where you will find the biggest difference between like the open source, let's say, ecosystem and more specialized, proprietary systems. And also, I tend to prefer solutions that are just the most Kubernetes possible, working in the Kubernetes space. Like what VMware did with vSAN was amazing. Nutanix, VMware, all the hyper-converged environment. I really love that. I think it was a game changer. This is why you don't see so many SAN today. It's all like they all died somewhere at some point. I think Kubernetes has the power to do the same thing, like have a distributed storage. If you think about it, every VM, every Kubernetes node has local storage, right? You can convert that storage into a distributed space for running stateful application, or not even stateful application, whatever you need.
What else? Let's see. When you run, this is, I would also like to, because I assume that the question goes for applications that are not writing to disk, right? In memory applications.
Yeah. So, but I believe Elasticsearch still needs persistency. I believe there are some stateful sets in Elasticsearch, right? When you deploy it, or you can do it NFS probably. But yeah, if it's just in memory, you don't necessarily need a stateful set or persistent storage as easy as that. But sometimes even stateless application have a stateful component like storing configuration, or even, I'm thinking about Tecton, for example. Tecton has an interesting issue where when you want to make tasks talk together, you need, Tecton is not necessarily persisting anything to disk, right? But when you have like a pipeline and you want to pass the result from one task to another, you need a PV, and you can have one per pipeline, if I remember correctly, only. But if you are using other solutions that help with this, then you can have more than one, right? So there are use cases, even though you may think it's just memory and no need to persist data. As soon as you have a persistent volume as part of the Helm chart or the how you install the application, then you have to take a look at how the persistent volume is used and what is expected. Because if you have a node failure and the pod need to be rescheduled, then you're screwed. It won't be rescheduled. So.
Because even when a database is full in memory, it still creates backups, right? Mm-hmm. Which would still need some volume attached. That would make it stateful set, right?
Yeah, exactly. So usually what I do when I want to install a solution, usually Helm chart or manifest, whatever, just grab for PV and PVC and just take a look at how it's used. And based on that, then you can deduce kind of your requirements. What are going to be your requirement, and test failure scenario. What happens if I lose a node? What happens if I lose, the volume? If the solution needs to restart without this, with a fresh PV, what happens?
Okay, do we have more? Oh, the best way. You need to give us only one way to do it.
Yeah, that's the best. That's the right way. Yeah, there's only one way. It's exactly. The way that works. So I would say there are multiple ingredients to run a good. The good way of running stateful application. So most of the time, as I said, if it's your own application, just use the right manifest to build your application. You have to design your application to run in Kubernetes. So again, stateful set, you need volume claim templates, you need headless service. It's more complicated than the basic deployment. But if you want to combine it into a solution or install a solution that relies on stateful set, then there is two layers. There is the manifest of the application, that is one part, but then there's also how do you install it? How do you manage ongoing operation on the application? So at the Kubernetes layer first, but then at the application layer. And this is where you need an operator so that you can, what happens if I scale up my stateful application, right? Because we are talking about pets. Every pod has a unique network and network identity. So you have to be careful about that. So most of the time you have to rely on that operator to run the application on top.
I was going there. Am I wrong if I say that actually that isn't or shouldn't be even a choice? It should be up to database vendor to say, this is how you run it, right? Potentially operator, because I know what I'm doing, kind of like you don't type of stuff, right?
Yeah. Mm-hmm. Yeah, and you're exactly right. I think the vendors or DB providers, they have their own operators, and they are good. Most of the time. But the problem I have with operators in general is that they are lacking not necessarily the documentation, because you find different examples in the Git repo. But most of the time, every customer has distinct requirements, and there's not one size fits all. So you will have to take, different elements from example, combine it into your own, custom resource, and it can take time to figure out what you need actually to make your stateful app work, and to understand how the operator has been designed. So you can still do things like kubectl explain, and it should work for CRDs as well. But my experience with operators, I spend a lot of time trying to figure out, how can I do this? How can I change the storage class? How can I change the permission for my database user? These kind of things, right? So it takes time, but that's the right way to do it. And also, the second thing is, depending on the operator, you have companies, their specialty is to build operator, like Kona. They provide, they help you build those databases. So you will find they have MySQL, Postgre, Mongo operators, that's fine. They will also wrap other things into the operator, or you can use, let's say, the MongoDB operator, and then you have, again, two choices. You go for the community one or the enterprise one. Enterprise one, you need to subscribe to Atlas, and then this marketing thing. So there's always different choices. Just try them all, pick the one that works the best for you, and you will have your best solution.
Okay, does Kubernetes operator? I think that we just answered that, right?
Yeah.
My summary would be, it really depends who created the operator, right? Test. Is there an open source project that federated Kubernetes stateful set across multi-Kubernetes cluster?
So by federation is like
KubeFed
V2.
Kube Federation is essentially dead, right?
But that's a V2. KubeFed V2 was published a couple of. I think. I remember last year we did some project. I was with another company 1.5 years ago. We did some project on KubeFed V2 for networking, combined with external DNS. That kind of worked. Now, it was not for stateful set, but the problem with this is, what would be the objective? Is it DR or just, load sharing, or I don't know, because the storage system would be different. Ideally, you would want, if you were going into this kind of solution, you would need a solution that allows you to replicate storage between clusters, right? So that you can, if that's DR, you can easily, shift left, right. So yeah, but I'm not sure you're right. KubeFed is not necessarily.
But ignoring now that, let's say that KubeFed works or it doesn't matter, but kind of running an application. I'm using application because it could be a database, it could be across multiple clusters. To me, in my head, that makes sense either because you're running at such a scale that a single cluster cannot handle it, which is not the case for majority of people, or we're talking about spreading across multiple regions. But then multi-regional database, would that work?
This is why
multi-region is the main motivation, right?
Yeah, DR kind of thing. This is what I was thinking in terms of DR, like a hot standby kind of thing, where you have the data that is available in another cluster, this kind of thing. So you can restart the stateful set there.
But if it's a DR, and correct me if I'm wrong, right? For DR, we need to figure out two things: how to run application in, let's say, 2 DCs, and how to replicate data. Now, if you do replicate data, then do you really need to run the database? Starting something is easy. Kind of, in case of a disaster, I can start something in seconds. The real thing is whether you replicate data, right?
Yeah, exactly. What you need is just the data, essentially. You need the data to be there, and then you need, at some point, there may be some IP issues because stateful sets are unique by design. So, IP address from one site are not the IP address from the other site. So you want to make sure that the operator can deal with, as long as you have the data, it doesn't matter if the identity on top of it is not the same. I think you can probably figure it out. But again, what is you have to also test it. Is it faster to do that or just have backup and restore as opposed to replication between cluster and these kind of things? But definitely stateful set is so specific that I wouldn't necessarily recommend a multi-cluster usage for that, except if that's distinct databases that have I don't know, maybe different purpose. So it just happens to be multi-region, but without necessarily sync. It's just distinct clusters. Just happens that you manage them or you want to manage them from a single pane of glass, and then you can use Rancher or whatever.
I interpreted that as no. Short version.
Yeah, it's too much. It's already complicated to run stateful set and databases at scale. Yeah, you don't want to do this to yourself. Run them in multiple cluster. Yeah, complicated.
I'm still wondering if there is a survey that shows how cloud native apps using storage in terms of access modes, backend technologies with large scale and multi-tenancy, etc.
There are some reports out there. So I think if you go on the, I want to talk about the DOK community, so data on Kubernetes, if you're interested. So this is the main community around, running databases and stateful application on Kubernetes. There is a DOK day, etc. So if you want to participate, you can also go there. And there's also a website, dok.community, and then the first page, I believe there is a report. So top of my head, you can find a lot of information there on how people are using Kubernetes and database on Kubernetes, all this kind of thing. I'm not sure it addresses all whatever is mentioned there, but that's definitely a good start.
Okay. Hey, hello Victor, what's the fast way to implement stateful Kubernetes app and what to do not with stateful Kubernetes apps? I mean, I think it's what you said, Nick, right? The major difference is that each replica gets storage. At least that's and that we know in which order pods will start and shut down. Kind of like we know the ordering. And I don't think that there is any other difference, right? Beyond that, they're the same.
Yeah, I mean, a couple of things, right? Kubernetes always makes sure that you have at most one single instance of what you want, because sometimes with deployment, you have at any point in time, depending on the situation, you can have more pods. That's what you wish, right? That can happen. For stateful set, there are strict guardrails for that. And the requirement, you have to be careful again, right? You need a headless service. So a service without cluster IP. Then you need a persistent, so the volume claim template, as opposed to a deployment, it's a bit different. And then, of course, you need to pick a CSI, preferably that can do dynamic provisioning, so that as soon as you specify the PVC template, it will dynamically provision the backend PV as well, right? So you have to check. There's a couple of check, right? Headless service, volume claim templates, which CSI to use, and the ordering. Yeah, you have to pay attention at your application, and in the documentation you will probably find, like a couple of things to be careful about. But yeah, basically the order, CSI, install the proper CSI, creates the stateful set manifests in the template, add the volume claim template, specify the storage class there, create the headless service, and you're done. That's good. And then you can scale up, scale down. But again, remember, the application doesn't scale with the pod. It's just, Kubernetes is just providing a new pod with the container image. That's it, right?
Okay. Would you recommend running Kafka on Kubernetes?
Yes, same thing as database. I don't see why you would not. You can run anything in Kubernetes right now.
So,
as long as you have the right compute, right? So Kafka is probably more memory intensive, but if you have enough memory in your compute node, that's perfectly fine. And again, Kafka at some point with the ecosystem it's managing or interacting with, you will need to persist some data anyway. So you will need some stateful set as well.
What will be the disaster recovery scenario for stateful set?
So disaster recovery, 0, 1, 2. So again, I think you have to decouple the data from the identity. If you need to hard code anything, then you will be in trouble. But typically, it doesn't matter because you can kill your pod, right? So when we say disaster recovery, let's talk about the same cluster first. If you have a couple of nodes who died, first thing, the storage needs to be replicated. There's two solutions, right? For stateful sets and PVC, if you want every pod to have its own storage space, if this is not NFS, then it means the storage is typically local to the node. If the node fails, you lose your storage. So the pod cannot be restarted on any other node. So therefore, you need a proper solution to do that. That's point one. If you can do that, if the solution you use, OpenEBS, on that, whatever, if you can guarantee that the storage, the volume are available on other nodes, then even if you lose the node, the data is there and the pod will be restarted with the same identity. So it's within the same cluster is kind of a non-issue, because even if you kill the pod, the PVC is not deleted. It's just reattached to the future, next stateful pod that will attach this volume, and it will have exactly the same identity. When I say exactly the same identity, it will have the same name. IP may be different though. Right?
So, and how about, I'm asking really because I'm not sure myself, if the data is replicated within multiple replicas of a database, then can you start from scratch and assume that actually it will pick up the data from the other replicas, right?
Yeah, completely.
Kind of
so
like
for example,
fresh storage in a way.
Oh, fresh, you mean like replica, database replica, not volume replica?
Yeah, so if I have 3 replicas of a database and they all have exactly the same data replicated across those 3, and one is shut down, can it start fresh? And would it even make sense to start fresh and say, okay, so I'm going to ask one of the other replicas to kind of like
that should work. That should work, because you have, as long as there's no like quorum thing and the database is automatically put into read-only mode. So there's two different solutions. If you don't have the data, of course, some database, if you just add a new member, will start replicating at the application level. So that works. But what you want to do is the minimum effort to recover, right? So in that case, it's still better to have the volume-based replication, so that the only thing that needs to be done is the scheduler to create the pod back, right? So MySQL-0, for example, was running before, the node died, MySQL 0 is recreated on another node and attached the old PVC. So it's much less effort than having to create a new pod and asking the database, okay, this is the replica, now you have to replicate that. The operator cannot do this easily. It would be like scaling again the database, right? It's like the prior one never existed.
And if I understand right, in that scenario, you recreate the replica, it attaches itself to the volume that has the data, sees the failure, and then it would pick up the missing data from other replicas, right? Kind of like what happened
the
between
meantime,
failure and then you reduce actually that the traffic required to put it completely,
So both work, is just a matter of the requirements.
Here's a question for you. If I have an application that is storing the state in a database, is that application stateful or stateless?
Every application is stateful. There's no such thing as a stateless application, because at some point, if it's like the minimum, if one component in your application is stateful, it's like the weakest part of your application is stateful, then everything can be considered stateful. Because if you lose this stateful component, your application doesn't make sense. So as a whole, an application cannot be completely
as a
stateless.
system, right?
As a system, exactly.
So would you say then there are stateful and stateless components?
Yeah, sure.
But everything as a whole is stateful.
Yeah.
There is always
state. Yeah, exactly. Yeah. You have like the front end, which may be a deployment, and then the deployment talk to a MongoDB cluster, and then the MongoDB cluster would be a stateful set, but your app, your front end would be a deployment, and therefore would be stateless. Right. So, yeah.
Okay. What Shrikant, we have a question from, I don't know whether it's a message or a question. Had an issue while simulating disaster recovery on RMQ. PV0 was out. Okay, you read it. It's too complicated for me.
Okay, I had an issue with simulating DR on RabbitMQ. So PV0 was out and only 1 and 2. So I guess you had a 3-node cluster with PV0 was right on node 1, PV1 on node 2, etc. Or is like 3 PV on the same machine. Anyway, so it was out and only 1 and 2 were there. Had to recreate the stateful set. What would be the right step in such scenario? It depends on the type of failure, right? Again, if you're safe by keeping the data, right, then it doesn't matter if you have to recreate the stateful set as long as you have the data, right? So again, the thing is, if you have a dependency on the local data, try to implement a solution that does replicate the volume, because again, Kubernetes doesn't do anything to replicate your volume or to make sure that the data is where you as an admin you would expect. So yeah, if you need to recreate actually you want to be in a position where when you have, or if you lose all your pods from your stateful set, as long as you have the content of the PV somewhere in the cluster, the scheduler will be able, just how Kubernetes work, it will recreate the pod, and the pod will get reattached to its own data, and the application on top should resync. If you do that, in my opinion, you should be safe. So pick a solution that can provide you this kind of mobility of your data within Kubernetes, so that you can, even in case of failure, Kubernetes, the only thing it has to think about is, I'm recreating the pod. I didn't delete any PV and here it is, and that's it. Just make the PV available, and then you're safe. That should be the step to take into account. Yeah.
I see from Valid few tips. I think that questions are not coming anymore. Yes,
you can relax the order for stateful set to pod management policy. Well, that's correct.
While waiting for questions, another reminder: join the channel, subscribe, like it, all the stuff that you do with other channels, do it here as well.
Click, go crazy.
Yeah.
Okay, I saw some operators not utilizing stateful set API. Okay, but creating a raw pods. Would you call this an anti-pattern? Definitely. Should every stateful application be?
Wait, I mean, that depends, and correct me if I'm wrong, how operator is implemented. Operator.
I mean, we're talking about database or?
Yeah, let's say
we're
it's a
talking
database.
Yeah. If it's a database.
But I mean, theoretically, and I think in practice as well, if operator is taking over the function of stateful set to manage you could have a new resource called Victor that is acting as a stateful set and managing the pods, right? Nothing prevents you theoretically from re-implementing stateful set-like functionality, but it cannot be only pods. It cannot be only pods.
No, and then you have a big issue. If it's how do you manage different you would have to find a model where every pod can be attached to a different PVC, right? That's the main thing. How then would you attach pod to different PVC, because they wouldn't be part of the same construct. Those need to be like individual pod managed by another intelligence that can basically define individual PVC and PV for those pods. So I would say if people do that, just to emulate what a stateful set is, they are doing a lot of work for just what is already there. But if we're not talking about database, like an operator to deploy, I don't know, something that is not stateful, then yes, that's fine. You don't need the stateful set API. Right?
Even in those cases, it's fine, but still you need a higher level construct. It cannot be only pod, because the pod goes down. Kubernetes will not restart pod. Deployment or stateful set, or I don't know, it could be something
except
else.
Static pod, right? Except if you define a static pods.
Are they them?
Yeah, it will restart. Yeah, static.
Really?
Static. Yeah, static pods, because they are, on the master in what's the it's in the
You mean on
Kubernetes,
management nodes, on master
Yeah,
nodes?
like
Yeah,
you
yeah.
have, like, when you run all the component as container,
Oh, yeah.
you can place static pods configuration there, and then there's no like controller associated with. I mean, like probably an implicit
True.
controller, and that's the only way I could see how you can do that. But yeah, you need something on top of that.
I saw that only on master nodes. I never saw.
Yeah, exactly. It's just
Yeah.
it's just on master node for sure. I mean, can you do this on work? No, I don't think so. No, I don't think so. And I think there was also a second part of the question, which was stateful. What was can we run stateful application outside of a stateful set? Something like that. Should every stateful application? Yeah, definitely. If you cannot solve the problem Victor mentioned around restarting the pods and attaching individual volumes, if you're not using FS, then yeah, it has to be a stateful set. Otherwise, you will have problems with naming, with the DNS name, things like that.
And if it's not stateful set, then you would need to ensure somehow that. Then correct me if I'm wrong, but then the volume would be the same volume would be attached to multiple replicas, and then
the same volume is attached to all pod. Yeah,
exactly, and you would need to ensure somehow that those processes in different replicas are talking to each other, so that only one of them is writing to that.
Yeah, it's even worse, because if you use so you can try it. I mean, everyone can try it by yourself, guys. Like, create a deployment and attach a PVC that is local to the node. Create, 5 replica deployment. Only one pod will be able to start. That's the one. The first one will kind of, grab the PV and the PVC. The other ones, they won't be able to start because they cannot attach the PVC. Right. So that's
unless if it's NFS.
Yeah, of course.
And then they would need to figure out different probably
everyone
create
can
different
have a directory.
directories.
Yeah, you can. There's a configuration when you can attach in the manifest, like every pod can be attached to a specific directory within the NFS volumes.
But it's kind of too much trouble to be worth it. Kind of like,
you're asking for it. You're really asking to get beaten by Kubernetes.
No, that's good, because if your intention was to prove that you shouldn't go to Kubernetes, this is a safe way to do it. To your management, exactly. Kind of like, you see?
Yeah, it's easy in Kubernetes to pick the wrong choice and not noticing it, and it's just like down the way what I did was just so stupid, And I'm sure. I mean, I had this kind of. I mean, a lot of time I had these moments in Kubernetes, like, oh, man, was not using. It was not. What's happening was not expected. Oh, but it's my fault. It's layer 8 issues. Well, that was a network joke. Sorry, I'm coming from a network background. Layer 8 issue means like between the desktop and the chair.
Yeah, I just hope that you never tried that on a date or something like that. Should application be responsible for managing data replication by writing to Redis before writing to database, or it should offload this job to replication management to database operator?
I don't see. So
isn't
Redis,
that too much over? Yeah.
What Redis write to a memory database? It's just Redis is just a cache, right? So it doesn't at some point.
I mean, theoretically, and I'm saying this theoretically, right? You can use Redis as even bus.
Yeah.
And then kind of theoretically, other instances could be picking up from there, but that's such an overhead, man. I mean, isn't that the responsibility of good database? I'm saying good, not every, to actually handle those things.
So again, there's 2 levels. Database level, the database operator should, by default anyway, when you construct your database, whether it's sharded, cluster, whatever, the operator needs to make sure the data is replicated, whatever mechanism. That's one. Application level. And then second, storage level. Because even though you have the data that is replicated, this is what we said before, right? You don't want to be in a situation where you have to start with 0 data, with a fresh, empty volume. That doesn't make sense. So therefore, pick a solution that does replication, then your RTO, RPO will be a lot less, for sure.
Deployment versus stateful set, when to use one and when the other. I find myself using deployments for everything and adding PVC templates where needed.
Yeah, that's right.
I think you answered already that, right?
Yeah, so PVC templates mean that if you do this on a deployment, it means you're using NFS, right? Because otherwise it just doesn't work. If you add a PVC template with like local path or something like that, that doesn't work. It just works with a single pod.
And it's
so this is why you see. Yeah.
And it's more effort, kind of like, so, you're fighting against something and then involving more effort to make it somehow work, and it doesn't work and stuff like that, right? Stateful.
So, for example, like if you go to the CKA, all the CNCF kind of exams, you see PVC and things like that, but most of the time you have a single pod, you have a deployment with a single pod, right? So of course you don't have any problem using like locally attached PVC or this kind of thing. But yeah, if you have multiple pods, if you use a deployment, if you create a PVC, a template within the template of your pod, then that won't work unless it's NFS. So if you're using NFS in a deployment, that can work. Again, this is what we said before. You have a directory within the shared volume, etc., etc. That works. If it's not a database, if you just need to store some files, or why not? Why not? Really. But if it's a database, no, for sure. Or message queuing or anything like that.
Oh, we got new member, Valid. Thank you so much.
Yay!
I would have, if I knew that you would join, I would have brought champagne bottle and open it. Running water. Databases, shame on you. Coke, I'm not much better. Running databases on Kubernetes is better than managed cloud databases in terms of cost.
Of course,
there's
no. I mean, of course, as part of what I'm doing on a daily basis, talking with our sales team, marketing team, we did some research on that, and actually, it's part of not only us again, but everyone in that space who provide distributed storage for Kubernetes. It's one of the main punchline, right? Of course, you need Kubernetes skills. But if you want to scale, it's easier, right? It's a lot easier, and Kubernetes is less expensive. Again, if you're using your own SSD drive, even if it's ephemeral storage and find a way to replicate that, then it's really a fraction of the cost at scale again, right? But of course, you need the skill set. You need to train people to understand how to operate database. The database admins need to learn a little bit of Kubernetes. Not that much, because operator, they solve a lot of things. But still, it's not a simple journey. But I believe every enterprise level company who are spending tens of millions in RDS and all the database as a service, if they have the in-house skill set to build themselves a database as a service. Actually, I've been writing some blogs and stuff on how to build database as a service with Kubernetes. Once you have, Kubernetes gives you a lot of benefits: redundancy, scheduling, YAML, which is awesome to manage features, right? And it's just native. So, there's nothing new when you put a database inside Kubernetes. And you have performance with the operator, you have the operation that is covered. So what is the argument to pay the extra money for RDS other than I don't have the skills? Like matter of second, you can build database as a service in a matter of second in Kubernetes, like storage class, YAML, customize, pipeline. You have all the tool set that is available, and Victor covers them all on his YouTube channels. This is where I'm learning too. So we've got everything you want. So definitely costs, and EBS cost is not something that is cheap as well, or Google persistent storage. All that is kind of expensive. So yeah, definitely save money.
What are the recommendations, stateful set and upgrade strategies?
Yeah, so I think now it's been like a couple of I would say like when was the latest updates for upgrade strategy in you can do running upgrade now with stateful setfall. You've been, I think, for a long time now.
Yeah,
So
from
it's
very early, yeah.
Yeah, but I can't remember, like a couple of months ago, they added also that there was a couple of things that was missing, but now I think it's pretty much all caught up with deployment. So you can treat, really in terms of upgrade, your stateful sets as your deployment. But again, remember, if we're talking about a stateful application, it means that it's upgrading the image, right? That's fine. And every operator has an upgrade documentation. So just follow the documentation that is there. And normally it's just a matter of changing, the container image, and maybe there may be like one or two extra thing you need to configure in the custom resource, right? That's it.
Okay, we have 10 minutes left. We need to stop
already?
at the top of the hour no matter what. Yeah, means you've been having fun. Good.
Yeah.
Let's see, one or two more questions, and maybe you can give a short pitch about on that at the very end.
I can do that. Yeah, I can do this a little bit. So this one is interesting. That's a very good question. Why do it work? Oh, yeah. Let's say, like, how can you do if you don't have enough space on a PV? So there's different solution. My preferred solution is typically, you should have a solution that is intelligent enough to talk to whatever is your cloud provider, maybe using another CSI or something, so that you can add new disk, right? Like if you don't have any PV space, meaning that you don't have disk space anymore. If you're using cloud, of course, then you should be able to interact with the API to produce a new volume. You can do this kind of stuff with cross-plane, I'm sure. So you can also combine this into your declarative way of operating the cluster. There's multiple ways to do it. If it's on-prem, then you're a bit more in trouble. Right? So that's the benefit of using cloud. Except if you have like a cloud-like management of your own data center, like you have an API to provision your storage and everything, which probably is not the case. I mean, I don't know, but typically you want like to trigger something that will provision new drive and new space for you. And as soon as you do that, Kubernetes will recognize that. And the CSI typically, actually not Kubernetes, but the CSI you use should be able to dynamically use that new storage to create new PV from the PVC. Yeah, that's it.
Okay, I would like to know. Actually, I have a strong opinion about it, but let's see you first.
I don't have any strong opinion on that one. Vitess seems to have. I didn't test many of them, so I'm not sure I'm the best person to talk about those new framework. But definitely Vitess, because it's part of the CNCF. I think there's also like an offering on what's the name, PlanetScale maybe, that is using Vitess as well.
Yeah, but I think that Vitess is great, but from my perspective, it is more about uncovering the efficiency of certain databases. I expect the database that I choose from a vendor that I choose to actually do the things that I do not. If I go and say I want this database and then the answer is best to run it through Vitess or whatever else, then to me there's a problem there, right? I'm not trying now to discourage Vitess. I think it's great, but I think the databases should do better.
They should.
There shouldn't be a need to say, hey, we do not run well, but actually if you have some other service, then it will be okay.
Yeah. It's the same principle of, any other option for Postgres. You can use many different operators. Probably Percona is the same thing. It's more opinionated because it's also combining other features. The operator itself is a framework. So, it's if you can find, I would, as you said, Victor, I would prefer to go with the database provider or vendor and use their operator to help me running that database rather than you're using something else. But if you have many different databases and Vitess can just unleash all the power of all of them, and you prefer to operate with kind of a single pane of glass to do everything, then yeah, why not?
Yeah, that's a good use case though. Okay, almost there. Tell us, what the heck is on that?
So on that, or formerly known as Storage OS, so maybe some people know on that from before, when we were called Storage OS. So what we do is, again, I was talking about vSAN and VMware. We are the vSAN for Kubernetes, and our focus is really for people to be able to run those stateful applications at scale by doing different things. So, we do a lot of storage stuff, but storage is boring. I don't want to talk about this. It just works. Like storage works. It's right or wrong, right? It's basically that. If it doesn't work, then you don't want to use the solution. But what we focus on is really to make persistent volume as easy as the access and the provisioning of application distributed storage for developer as easy as possible. By what I mean by as easy as possible is just adhering to all the Kubernetes primitives. So you want to enable encryption, go to the storage class, add a label, encryption equal true. These kind of things. It's all this kind of on-demand and also shift-left paradigm. So for example, you could, as a developer, you start developing an application and you want to do some performance test, or you want to test other things very easily into your smoke test locally, or just basic testing. You will need like a local Kubernetes cluster. And what do? If you don't have the same qualities or feature as what you have in your dev cluster remotely or in your prod cluster, you need the same consistent set of tools. So with on that, essentially what it means is when you create your application and your application manifest, you can put all your volume or data services requirement collocated with your application requirement, like all your environment variable, the volume and the data services aspect just become another section into your declarative YAML manifest. That's the idea, right? So it's reduced the friction between the dev and the infrastructure. So basically between the DevOps admin and the developer, because the developer doesn't care about the infrastructure. Simple.
Hey, thank you everybody for watching. Thank you, Nick. This was brilliant. This is the first AMI section where I wasn't talking all the time, so I really appreciate it.
Thank you, Gabe, for having me. That was great.
Yeah. See you next time. Cheers, everybody.
Thank you. Bye-bye.